Welcome to Miss Smith's Math Tutorials. I'm Miss Smith. In this video, we're going to be talking about writing polynomials given roots. So essentially what that means is we're given the answers to the polynomials, like as if we've solved them, and then we want to work backwards to figure out what would the original equation have been. We're going to follow some really simple steps. We're going to set each root equal to x. And there's a very special rule we need to follow when we do imaginary numbers and radicals. Whenever we have an imaginary number or a radical, we have to remember that they come in pairs, conjugate pairs of positive and negative. So we don't have any on the first page like that, but on the second page we'll see this. Our next step is going to be to get each equation equal to 0. Our third step is going to be to multiply our factors using FOIL or distribution, however you want to do it. And then step 4 would be to write the polynomial in standard form. So once we get our final answer, we just need to make sure we're writing it with the highest exponent first, then the next highest exponent, and so on down, and then the constant last. So we'll see all of these steps in action. Okay, so in this first example, it says to write a polynomial equation with roots of -1 and 3. So what they're saying, and also with our first step, it says set each root equal to x. So what we're saying is that when we solved this polynomial equation, we got answers of x equals -1 and x equals +3. That those were our answers. We would then want to follow our step 2, which says get each equation equal to 0. So this goes back to using just our basic algebra. If we want this to say x equals 0, we need to move this -1 to the other side. And I would need to do that by adding 1. And same thing here, adding 1. So when I do that, I get x plus 1 equals 0. So now we've done step 2 for the first equation, but we need to also do it for the second equation. So this one says x equals 3. I need to move this 3 to the other side. I can do that because it's a +3, I'm going to subtract 3. And that means it will cancel on this side. I need to do the same to the other side. So now I have x minus 3 equals 0. We've completed step 2. We got both equations equal to 0. So now we want to move to step 3, multiply the factors. Our factors are right there, x plus 1, and right there, x plus 3. So we want to go ahead and multiply those factors together. So we've got x plus 1 times x minus 3. And they equal 0. This is a binomial times a binomial. I traditionally like to FOIL, that's just my personal preference. You might have been taught to distribute every part of this binomial to every part of this binomial. It's the same thing. Okay, so you just do what works for you, but I'm going to show FOILing. So for FOIL, we do our first, so x times x is x squared. And then we do our outer. So x times -3 is -3x. And now our inner, so 1 times x is +x. And our last, 1 times -3 is -3. We still have this equals 0. So at this point, we want to combine any like terms, and we want to make sure we write our answer in standard form. I have a like term right here and right there. Those are both x's, and you might be thinking, well, what about x squared? Well, remember that when we're adding or subtracting, in order to have like terms, it has to be not only the same letter, they both would have to be x, but they have to have the same exponent too. That guy has an exponent of 2, whereas these two middle terms have an exponent of an understood 1, an understood x to the first. So we can only combine our like terms. Let's just bring down our x squared. And then -3 plus 1, that would give us -2x. And then we still have our constant, no like term there, so we'll just bring it down, equals 0. We have now figured this out. We've got a polynomial equation. It's a quadratic, which makes sense because I have two answers. But if we were to factor this, we would get an answer of x equals -1 and x equals 3. If you were to graph this, it would show that the parabola crosses the x-axis in two places at -1 and at 3. So again, we're kind of just completing the circle here. So a lot of the times in math, we focus on starting on the polynomial and then getting the answers. This time we're starting on the answers and getting the polynomial. Let's do another example. Write a polynomial equation with roots of 1, -2, and 2/3. There's a couple of things I can definitely figure out just from observation. Notice we have 3 answers, which means when I get my final polynomial, it should be a cubic polynomial, meaning that the highest exponent I see should be a 3. And I know that because I have 3 answers. So just like here, I had 2 answers and my highest degree was 2. In this one, my highest degree should be 3. But our steps are still the same. Our first step says write each root equal to x. X equals 1. We've got x equals -2. And then we've got x equals 2/3. And I know fractions are scary. I know people don't like them, but you'll see that really it's not so bad. Now we want to do our step 2, get each equation equal to 0. For this first one, because this is a positive one, we would want to subtract 1 from both sides. Then we would have x minus 1 equals 0. And then for x minus 2, because that's a -2, we'd want to add 2 to both sides. And we'd get x plus 2 equals 0. And then for this fraction, this is actually a 2-step instead of just a 1-step, because remember, how do we get rid of a fraction? We can always multiply by the denominator. That gets rid of the denominator, and if we do that to one side, we have to do it to the other. So at this point, we've got 3x equals 2. And we're really close to having equal 0. Now we just need to use this inverse step like we did here. We just need to subtract 2 from both sides, and we get 3x minus 2 equals 0. Now we're ready for our step 3. Step 3 says multiply factors. We have our 3 factors. We have x minus 1, x plus 2, and 3x minus 2. Over here on the side, we want to multiply those 3 together. X minus 1 times x plus 2 times 3x minus 2. So this time we're not going to multiply these all together at once. What we're going to do is we're just going to take the first 2, we'll FOIL those together, and then once we have that answer, then we'll multiply it by the third. That's going to be the easiest way to go about this. So we have x times x, which is x squared. And then our outer, x times positive 2 is positive 2x. And then our inner, -1 times x is -1x. And -1 times positive 2 is -2. Now, we do have some like terms here, so to kind of save some headache, let's go ahead and combine those 2 like terms before we multiply the third. It'll just save us some work in the long run. 2 minus 1, that would give us, so we got x squared, and then 2 minus 1 is just 1, right? Just a positive 1x. And then we have our minus 2. So now we want to take this and multiply it by that binomial, 3x minus 2. So we're just bringing that down. Now here, we can't FOIL, because I know a lot of students they try to, okay, well, let me do my first, my outer, my inner, my last, but then you're leaving things out. You're totally forgetting about that middle term there. In this case, we can't FOIL when we have a trinomial times a binomial. So what we're going to do is just our traditional distribution. We want to distribute every part of this polynomial to every part of that polynomial. We'll start with our x squared. x squared times 3x, well, that would give me 3x cubed. Remember, x squared times x to the first, we're multiplying, and our laws of exponents say that when we multiply a like base, we add the exponent. So just be careful there. So there's an understood 1 there. So 2 plus 1 is 3. Okay, let's keep going. Now we've got our x squared being multiplied by that negative 2. So that leaves me with negative 2x squared. And now we'll do this middle term of x. So let's multiply x times 3x would be positive 3x squared. X times x is x squared. And x times negative 2 is a negative 2x. And now we're ready for that final term of the trinomial. So this negative 2, we need to distribute that term to each of the binomial as well. We've got negative 2 times 3x, which would be negative 6x. And then we've got a negative 2 times a negative 2, which is a positive 4, equals 0. Now we want to make sure that we combine all of our like terms, and we also want to make sure we write our answer in standard form. This first one kind of naturally ended up in standard form, so I didn't really touch on it too much, but we'll make sure this one gets in standard form, and this one should kind of naturally fall that way as well. We want our x cubed, that's our highest exponent, we want it to go first. And notice I don't have any other x cubed, so I'm just going to bring it down. 3x cubed. And then we've got our x squareds. So I have this one and this one, no others though. So negative 2 plus 3, that would give me a positive 1x squared. Now just my plain x's. I've got a negative 2x and a negative 6x. Negative 2 minus 6, that would give me a negative 8x. And then lastly, I just have this constant. There's no other constants, so I just bring him down. And bring down my equals 0. We did end up in standard form, so we have our highest exponent of 3, then the next highest of 2, then the next highest of 1, and then the constant last. We are in standard form, and notice this is a cubic polynomial. Its highest power is 3, which it should be because we had 1, 2, 3 answers. Let's look at some more examples. Write a polynomial equation with roots of 0 and 3 with a multiplicity of 2. What that means is that 3 is an answer twice. So if 3 has a multiplicity of 2, that means I need to write x equals 3 2 times. And I do a whole nother video where I talk about writing polynomial equations given graphs, where I go into this a bit more, but I just want to show you, I've just drawn a little picture here just to give you a hint of what this means. This is a cubic function because it has 3 separate answers. X equals 0, x equals 3, and x equals 3 again. And what that would look like if we were to graph this is we would have a cubic function that crosses the x-axis at 0, and then what happens is when it gets over here to 3, it does something called a bounce, where it touches the 3 and then it goes the other direction. And when we have a bounce like that, it means that that answer has a multiplicity of 2. We've got 3 answers, so we've got x equals 0, x equals 3, and we have x equals 3 again. So what's interesting about this one is, notice we already have, when I wrote this first answer equal to x, it's already also equal to 0. I covered step 1 and step 2 within that same step. So that's fine. What that tells me is that just x is one of my factors. It won't be like x plus or minus a number. It's just x is one of my factors. And we'll see how that looks in just a second. Now for the other two, we do need to solve these for 0. So we would want to subtract 3 from both sides. and we get x minus 3 equals 0. Now here, I could do that step again, but isn't it just going to be the same thing, right? I just solved it there, so we know this one will also be x minus 3 equals 0. And so now we have our three factors. We have just plain x, we have x minus 3, and x minus 3 again. So now we can go on to step 3 and multiply these all together. We have an x times an x minus 3 times an x minus 3 equals 0. It's definitely going to be easiest to just distribute this x in to this binomial first, and then once we get that answer, we'll multiply whatever we get by our second binomial of x minus 3. X times x is x squared, and x times negative 3 is negative 3x. And so now we're going to take that factor and we're going to multiply it by that second x minus 3. So this time we can FOIL because it's a binomial times a binomial, so we can definitely FOIL here. X squared times x. Let's do our first. X squared times x is x cubed. X squared times negative 3, which would be negative 3x squared. Then we have our inner negative 3x times x is negative 3x squared. And then our last negative 3x times negative 3 is a positive 9x equals 0. We have some like terms here in the center, our x squared and our x squared right there. So let's go ahead and combine those. I definitely want to write my x cubed first because remember the highest exponent goes first in standard form. And then negative 3 minus 3, well that would give me negative 6x squared. And then we have this plus 9x equals 0. Just double checking back through, we had an x cubed as our degree, which makes sense because we had 1, 2, 3 answers. So this is definitely a cubic function. Okay, let's look at another one. Write a polynomial equation with roots of 2 and 4i. Now, if you have no idea what that I represents, it's an imaginary number. You're definitely, if you're like, what? You're definitely going to want to stop and review my video on imaginary numbers to kind of catch up on that. But that's what that I represents. So remember that in that first step, on that first page, we said step 1, imaginary numbers and radicals came in plus and minus pairs. Conjugate pairs is what we would call that. This time when we write, we're going to write x equals 2, x equals positive and negative 4i. For this first one, pretty easy. We've been doing these. Hopefully it's feeling a little more natural now. We'd want to subtract 2 from both sides and we get x minus 2 equals 0. So we're good on that first factor. Definitely one of our factors is x minus 2. But for the second one, we have to do a little bit more work. We've got this plus or minus 4i. Another way to write I, and essentially what I represents is x equals plus or minus 4 times the square root of negative 1. I is just another way to say square root of negative 1. We could rewrite it, and that'll help us see what needs to come next. Remember that I can get rid of a square root. I can get rid of this radical right here by squaring it. So the inverse of a square root is a square. What would happen is I'd take this whole side and square it. And when I do that, that gets rid of the little plus or minus, it gets rid of the radical. So we also need to make sure we distribute this power of 2 to the 4 as well. We would want to square 4. So 4 squared is actually 16. And then we've gotten rid of this square root, so all we're left with is what's underneath it, -1. So we've got now 16 times -1. But before we move forward and you say, okay, well, that'd be -16. Before we do that, we also need, if we're going to square this side, we have to be fair. We have to square the x as well. And x squared is just x squared. So now let's go ahead and simplify. What is 16 times -1? Well, that would just be -16. And then we bring down our x squared. And now our goal is still the same. So I know it kind of feels like we took a detour there, like all that to get rid of that, the I, and then the negative square root of 1. But at the end, our goal is still the same. We want this thing to equal 0. So now we need to add 16 to both sides. So now we have x squared plus 16 equals 0. And there is our other factor. Okay, so then our next step is we want to multiply these factors together. So we've got our x minus 2 times our x squared plus 16 equals 0. And we can definitely FOIL this because it is a binomial times a binomial. X times x squared, that would give us x cubed. And then x times positive 16 gives us positive 16x. -2, we're doing our inner now. -2 times x squared is -2x squared. And then our last, -2 times positive 16, which would give us -32 equals 0. So now we look and we try to see, do we have any like terms? And you'll notice that I actually don't. I have only 1x cubed, only 1x to the first, only 1x squared, and then only one constant. So I don't have any like terms. However, I do want to go ahead and write this thing in standard form because right now it is not in standard form. Notice I've got the cube first, which is good, but then I have the x to the first and then the x squared. So those two are out of order. Let's go ahead and rewrite it. So we've got x cubed. Next, I'll do my minus 2x squared. Then my plus 16x. Then my minus 32 equals 0. Okay, we're going to do two final examples together. So for this first one, it says write a polynomial equation with roots of -4 and 1 plus the square root of 3. Our steps are still the same, even though it looks a little more complicated. We still start off by saying, okay, one of our roots is x equals -4, and the other one is x equals 1 plus square root of 3. Now, be careful. Radicals come in plus or minus pairs as well. So when we write this, it's not really just 1 plus square root of 3. At that point, it's 1 plus or minus. And the reason why is because what that tells me is this is going to end up being a cubic function. So even though it looks like we only had 2 solutions, in reality, we have 3 solutions because that radical comes in a plus and minus pair. Okay, so let's go ahead and solve this. For our x equals -4, pretty basic. We just want to add 4 to both sides. So then we get x plus 4 equals 0. And then for our second one, we can't do anything with this radical until it is the only thing on that side of the equation. We need to subtract 1, and it's because of that plus or minus in between the 1 and the radical. We need to get this 1 over here first by subtracting it. So at this point, we've got x minus 1 equals plus or minus square root of 3. So it would be okay to have a number right there in between that plus and minus and the radical, like being multiplied by the radical. That's fine. But when we have this plus or minus and then a number in front of it, that means we need to get that number over first before we start trying to get rid of the radical. I hope that makes sense. So at this point, like I said, we've got that x minus 1 equals positive or negative square root of 3. Now we can get rid of that radical. And how do we get rid of a radical? We square it. The inverse of a square root is a square. So we take the side and we can square it. And when we do that, that gets rid of that plus or minus, it gets rid of the radical, and all you have left is what's underneath the radical, 3. So right over here, all we have left is a positive 3. Now we can't just square root one side. If you're going to square the right side, you have to also square the left side. So at this point, we've got x minus 1 squared. So we need to go ahead and take care of that. So x minus 1 squared is actually x minus 1 times x minus 1. And I know that can be confusing because a lot of people, I'm sure, because I see it all the time with students, they're tempted to take that square and just distribute it and make this an x squared and then make this a negative 1 squared. Here's the thing, we cannot do that. And the reason we can't do that is because this is a binomial. It is not a monomial. So if that was just an x squared, that'd be fine. We could take that 2 and distribute it, no big deal. But because it is an x minus 1, it's a binomial. And that means that when we square a binomial, we just write it twice. We cannot distribute that 2. It does not do the same thing. Okay, so just be cautious of that. At this point, we've got an x minus 1 times x minus 1 equals 3. So we can go ahead and simplify this binomial times a binomial by foiling. So first, x times x is x squared. Outer, x times negative 1 is negative x. Inner, negative 1 times x is negative 1x. And last, negative 1 times negative 1 is a positive 1. Equals 3. So let's go ahead and combine those like terms in the middle there. So negative 1 minus 1, well, that would give us a negative 2x plus 1 equals 3. So again, we've kind of gone off on a detour a bit. We were worried about getting this radical alone and then getting rid of the radical and then foiling, but at the end we're still on step 2. We're still trying to get this factor equal to 0. So it's almost equal to 0. I just need to subtract this 3 from both sides. And notice I put it right under that 1 because that's its like term. So we've got x squared minus 2x, and then 1 minus 3, that would give us a negative 2 equals 0. So now, there's my second factor. It took us a while to find it, but we know our first factor is x plus 4, and then x squared minus 2x minus 2 is our second factor. So now we're ready to finally move to step 3, which is multiply the factors together. So we'll do that up here. We'll do our x plus 4 times x squared minus 2x minus 2 equals 0. So let's go ahead and multiply this out. Remember, this is a binomial times a trinomial, so foiling is not going to cut it. We need to actually just distribute. X times x squared is x cubed. X times negative 2x is negative 2x squared. X times negative 2 is a negative 2x. And now we need to distribute that positive 4 to each of these parts. So 4 times x squared is a positive 4x squared. 4 times negative 2x is a negative 8x. And 4 times negative 2 is negative 8 equals 0. Now we do need to combine like terms and make sure we write our answer in standard form. My highest exponent is an x cubed. So let's go ahead and write that one. So we've got our x cubed. For x squareds, I have 2 of them. I've got this negative x squared plus 4x squared. So negative 2 plus 4, that's going to give me a positive 2x squared. For my x to the first, my just plain x's, I've got this negative 2x and this negative 8x. Negative 2 minus 8, that would give me a negative 10x. And then my constant of negative 8, no like terms there, equals 0. Okay, one final one to do together. So it says to write a polynomial equation with roots of 2 and 3 minus square root of 5 divided by 2. So we've got x equals 2, and we've got x equals 3 minus square root of 5 over 2. But remember, if it is a radical, we need to include both the plus and minus. Let's just do this easy one first. So we want to subtract 2, and we get x minus 2 equals 0. That's our first factor. That one was pretty easy. Now for this second equation, remember, anytime we want to get rid of a fraction, we just need to multiply it by the denominator. That cancels on the first side, and then we just need to make sure we do the same to the second side. So we've got 2x equals 3 plus or minus square root of 5. So now this one looks just like what we had here. We now would want to get this plus or minus square root of 5 alone on one side. That 3 has got to go. He's on the other side of the plus or minus. So when we're adding or subtracting, we got to get rid of him before we worry about this. Let's subtract 3 from both sides. So we've got 2x minus 3 equals plus or minus square root of 5. Now that I've gotten that radical alone on one side of the equation, I can get rid of it. And how do I get rid of a square root? I take the square. And when I do that, it gets rid of the plus or minus, it gets rid of the radical, and all you're left with is what's underneath the radical, 5. But if we're going to square what's on the right, we have to square what's on the left as well. So this is 2x minus 3 times 2x minus 3. 2x times 2x is going to be a positive 4x squared. 2x times negative 3, that's going to give me a negative 6x. Now our inner, negative 3 times 2x gives me another negative 6x. And our last, negative 3 times negative 3, which gives me a positive 9, equals 5. Let's go ahead and combine those like terms in the center. So we've got a 4x squared, negative 6x minus 6x gives me a negative 12x. And then I've got this plus 9 equals 5. Now remember, we took a long detour there, but we're still on step 2. We are still trying to get this thing equal to 0. So my final step to make this equal 0 is to get rid of this 5. Let's move it over to the other side. So we want to subtract 5. Notice I put it under the like term. So I've got 4x squared minus 12x, and then 9 minus 5 is a positive 4 equals 0. I want to take my first factor of x minus 2, and I want to multiply it by my second factor of 4x squared minus 12x plus 4, and they equal 0. So now let's actually distribute. X times 4x squared, that is 4x cubed. And then we've got our x times negative 12x, which would be negative 12x squared. And then we've got our x times our 4, so positive 4x. Now we need to distribute this negative 2 to every part. So negative 2 times 4x squared would give me negative 8x squared. Negative 2 times negative 12 would give me a positive 24x, and then negative 2 times positive 4 would give me negative 8 equals 0. So we want to combine like terms and also make sure we're writing our answer in standard form. So my highest exponent is x cubed. I don't see any other x cubed, so we're just going to rewrite that. So we got 4x cubed. Next will be my x squareds. I have 2 of them. Negative 12 minus 8. That's going to give me a negative 20 x squared. Next would be my just x to the first power. I've got a plus 4x and a plus 24x. That's going to give me a positive 28x. And then lastly, I just have my constant of negative 8. Nothing to combine it with, so I just bring it down. All right, here's one for you guys to try on your own. I'll post the answer in the video description below. This has been Miss Smith's Math Tutorials.